Good afternoon, everyone. I'm Stefan Wittmann. I'm delighted to have you for the next 45 minutes and talk a little bit about all the enhancements and changes we've done to language connectivity in general. So this is a pretty broad topic. Pretty many things we're going to cover. So let's check first in this room here. Who's using Java as a technology in-house? Just hands up. A couple. Who's using .NET? Okay, you're using all of it, right? JavaScript? No? Okay. And Python? That's a nice, decent mix. Okay. And who's using something else? Say again? Oh, wow. Okay, so in case you haven't met me yet, I don't know, I'm kind of the inventory here. So I'm a product manager, been with the company since 2006. I'm based in Germany. So if I speak funny, let me know. I try to speak slowly. But a couple of things we're going to cover here today. The first thing is all about client artifacts and where can you get them, how can you get your hands on them, how can we update them in a regular fashion, and what we're doing there. Then there's it's a bit heavy on Java today. There's lots of stuff happening in Java. So that's, I think, of interest to probably not, if you're not just developing in Java, if you're developing .NET, JavaScript, or Python, I think this is still worthwhile for you to look at it. And I want to hear from you if that's something that you would like to see in .NET and other languages as well. So give me feedback afterwards. The third part is something that's really dear to my heart, which is a topic that's very often overseen, is how can we keep our clients up to date? What's the benefit of doing it actually, right? Why should we care about updating our clients every once in a while? So I think that's a pretty important one, at least for me. And then I'm going to tease a new service, giving you a little sneak peek, which is actually going to be announced tomorrow at the keynote. So you're going to see some internals today, but not too much, because I'm not going to steal the thunder of the keynote, but you're getting to see something. So first of all, topic number one, how can you get your hands on client artifacts, right? Today, there are a couple of ways how you can get, let's say, your hands on the JDBC driver or the ODBC driver, right? You can go to the WSC page, log in, then you select the software distribution page where you can download your Iris kits or the containers. And there's also a section called InterSystems components, and that includes all the client drivers, all the jar files, all the NPM packages that you can just download. That's a protected area, right? You need to log in, so you need to have a WSC account. So that's sometimes problematic if you want to build it in a pipe or if you want an end user to download the driver. So that's not always perfect. There's a GitHub repository. I don't know if anybody here in this room actually knows this. There's a GitHub repository where you can download those drivers, get your hands on those. That's public. So that's a good point for pointing end users at it. But obviously, the one thing that we really want to get to is posting all of our artifacts to public repositories. So that's the ultimate goal that we're striving for. And we're getting really close to actually achieving this for JDBC. That's the one that's really on the horizon. Next step is probably going to be Python, and a couple more after that. So for Java, that would be Maven. For .NET, this would be NuGet, obviously, Node, NPM, and Python is PyPy. I'm going to take a little tour and give you some background in terms of what are we doing internally to get to this, what we call the direct distribution. So in the past, basically what happens is every client artifact was always tied to one version of Iris, right? It belonged to this version. So what this means is, in terms of testing, whenever we release a new version of Iris, we make sure that all the client artifacts that belong to that version actually work and function with exactly this version. As soon as we make those drivers available to you completely independent from Iris releases, what this means is we have to have a very clear communication with you and your users about which version of which artifact is supported with which version of Iris and what you can expect. So in that journey, what we've built is something that we call cross-version testing. So now we're not just testing this one version of, let's say, JDBC against this one version of Iris, but we're testing in a two-dimensional matrix with multiple versions of JDBC against multiple versions of Iris instances, because now everybody can get a version of JDBC, and you don't really know, does this belong to a certain Iris kit? No, it doesn't, right? It's just a version of JDBC, it's an independent release, and we need to make sure that it works with all kinds of different versions of Iris. The policy that we follow in general is that we test against the currently released EM release. The EM releases, extended maintenance, are the .1 releases. So right now 23.1 is the current EM. The next one, and the two EM releases before that, right? So that's the official policy we have on our website, the EM releases that we support. So in this case, right now, we would be testing against 23.1, 22.1, and 21.1. Those are the ones we're going to guarantee that they will work, right? The other ones will probably work too, but that's not part of the official matrix. So what you can see here is exactly this matrix. You don't have to try and read the tiny font. That's not the purpose of it. I'm just using this screenshot here to give you an idea that we're working on a matrix, which obviously makes testing a bit more complicated. The other thing, among many things, that I want to highlight here is that we are actually building our artifacts now in a completely different way. So early on, what happened is when we triggered a new build of an Iris kit, that at some point triggered the builds for all the various client artifacts for Java, .NET, Python, JavaScript. And we included those artifacts inside the kit. Obviously, that doesn't make sense anymore when we're talking about decoupling the clients from the server. So we've changed the build process in such a way that we have an independent build pipeline for each of those individual artifacts. We build them independently, not when we build a new Iris kit. And we store them in the local repository that we have within InterSystems, right? And then whenever we build a new Iris kit, we actually pull the latest released version of each client artifact and include that, right? So that's one of the many things, the last arrow. That's one of the many things we've done in order to get us into the position that we can release and post these artifacts independently. So just to give you a little bit of background on what we've been doing there. The next thing I would like to talk about a little bit is timelines, because that's an important topic that comes up every once in a while when I talk to a customer. And then at some point we realize that the customer wasn't aware that an important deadline is coming up. And when such a deadline is a surprise to you, that can be a big hassle operational-wise. So in these sessions, I usually like to highlight important end-of-lives that are on the horizon so that everybody can plan accordingly. For Java, I'm going to highlight that the jar files that we build are usually for Java 8 or Java 11. I very often get the question, does that mean we only support Java 8 or 11? And the answer is no, we don't, right? Obviously, we support Java 8 and up, but we build against the lowest denominator. So when you have a Java 17 project, You just pick the Java 11 artifact and include that in your project. But this allows us to basically also support Java 11 projects. So if you have a Java 11 project, you can still simply point to the same jar and it will just work. But if you would build a Java 17 jar file, you couldn't just include that in your Java 11 project. That's why we build for Java 8 and 11. With Java 8, you're pretty safe for a long time. Security support is still valid for the next 7 years, but there's no more active development happening there on that stream, right? So if you want to take leverage of the new features, you should definitely jump to version 17 or up later on 21 when that comes out. .NET it is a bit more, I don't know, a bit more aggressive in its release. Microsoft started that a while ago. The current LTS, long-term support, is .NET 6, which is valid till November next year. So an LTS with .NET is valid for 3 years by default after it got released. And the next LTS is on the horizon after 2 years. So that means .NET 8 is expected to be released November of this year. And since .NET 6 has another year till its end of life, that means you have exactly 1 year to go through all your clients and update them. So that can be a pretty tight timeline if you have lots of client sites, especially if you have sites where you need to physically go there in order to do the update. So if you're working with .NET, make sure that you keep a note, an eye out on this .NET 8 release. Okay, that's potentially a lot of pressure. Node.js is a bit more friendly. It usually comes out with a new LTS after 6 months after the release, so you have enough time to actually update your libraries, and then it's valid for 2.5 years. Python, by default, 5 years, so that's very relaxed. They've been on the 3x stream for a while, and I don't see Python 4x around the corner, so I think that's a really relaxed environment there. No need to hurry there, I think. So the big topic I wanted to talk about, and I'm very excited about this one, is the Java Persister. That's a new feature we are introducing for Java specifically. It's a new tool which allows you to do high throughput messaging between Java and your Iris instance. And what I really like about it is that it gives you a way to work very flexibly with your schema information. So you don't have a very rigid, a very predefined schema, but you can work with very flexible data models and send this over to your server, which I think is very interesting. By default, what you need, a couple of things. You need access to the JDBC driver, because as you may know, in Java, and we do the same thing with .NET as well, we always share the same connection for all the various artifacts that are running in that environment. So you need JDBC in order to establish the connection to the server, and then Persister builds on top of that. The Persister has a dependency also on Jackson, which is a library for working with JSON data types, but that gets pulled in automatically as soon as you use that from a repository. So here you can see the imports that you need, 2 from the JDBC package that comes from the JDBC driver, the Iris connection, the Iris data source that's needed to create the connection to the server. And then the main class that we care about is the Persister in the Persister package. That's the one package which actually includes everything that you need in order to work with your Persister. And the 2 main classes you're going to work with is Persister and SchemaBuilder. I'm going to talk more about what the SchemaBuilder really does, but to give you an idea, the schema is basically a representation of the class structure, the table that you want to work with on the server side. So it's basically the metadata describing what the payload looks like that you want to ship to the server. We call that a schema in the Persister. The schema builder is a way to, as the name suggests, to build the schema and tell the system what your schema looks like. The schema manager then is a way for you to take the schema and communicate with the server to synchronize it, right? Because depending on which server you talk to, maybe that server already knows this schema and you're all good. Maybe the server has no clue about this type of class, this type of a table, so you need to create it. That's what the schema manager does. So I always love getting into code and taking a look at stuff. So this is the very beginning, the typical setup that you need in order to create a connection to the server. Anybody recognizes that code? Yeah, a bunch of hands, right? So this is basic JDBC stuff, right? Nothing special, has nothing to do specifically with the Persister. It's just a standard JDBC connection, right? We're creating a new data source, setting the configuration parameters to where we want to connect to, localhost, standard port, the user namespace, standard credentials, very safe, obviously. And then we run get connection, and there we are, okay? The first thing we need to do as soon as we create the connection is actually establish what the metadata looks like. So we have to tell the system, this is what the schema looks like. The typical way how we do this, at least early on, is through the schema builder. And I'm going to show you what the schema builder, how you interact with it on the next slide to give you an idea. But what I want to highlight is that there are many ways how you can create the schema or load a schema in the Persister. The most straightforward way that we're going to use in the demo as well is we can interactively work with the schema builder to, let's say, give it a name like user.person and add fields to it, like a name, like gender, like a balance or a country. But we can also load a schema information through a JSON file, something that you've stored somewhere, or an information you're getting from, let's say, another REST service. We can also work directly with Afro schemas. So if you're interacting with another tool, another framework which works with Afro, that's something we can consume directly and create the schema from that. We can generate a schema based on a class that exists on the Iris server. So if you already have a class on the server, like user sample.person as an example, you can also say, hey, I want to work with sample.person. You already have that class on the server. Please generate a schema definition so that I can work with it on the Java side, right? And obviously, we can just go to the Iris server and say, hey, I've already used the schema in my last session. Please just use that schema under this name and load it, right? A couple of ways how we can interact with that. So a very flexible approach. And here's a very simple example of what this looks like when we build it interactively. I don't think the code is too complicated, but going through it, we're going through the schema builder class, calling the method record. We're going to create a new record, a new schema. And the first thing we define early on is what the schema is named, right? On the server side, this basically represents the name of the class, the name of the table that's going to be created to hold the data as a container, right? So what this actually means, as soon as we synchronize this schema, we're going to create a class called user.person, okay? And the table user_person. And then we're going to add a couple of fields, which translate to properties on the server side. And for each property, we're going to define what the type is, right? String, int, double, or whatever, a blob. And once we're done with this, we're calling the method complete. And what this basically does is it generates a JSON string, which includes the schema representation that we've just interactively built with code. We can then, if we want to, we can take this JSON string and save it in a file if you want to. We can ship it to another instance that can work with this JSON schema if you want to. Or we can take this JSON string and send it to the server and say, hey, create this class. Right? There are a couple of ways how we can work with this. What happens often in this case, just going back for 1 second here, what I've done here is I've used strings to say, hey, this is a string data type or an integer data type. What very often happens when you want to work with dynamic data structures, right? You get something from your Java application, you receive values. You don't have something like, I know this is a string as a string. You have Java data types, obviously. So we can directly infer which data type something should be within the persister based on the Java data type. So you basically just hand us over the native data type of, hey, this is a string, this is a double, this is a float, and we will generate the appropriate data type representation for the Java persister for you. So that makes your life a little bit easier if you dynamically generate your schema from a structure that you're using in your Java application. The next thing you want to do, well, usually, at least when you're going into production, hopefully, is you want to define an index so that you can query your data effectively. This is basically the same thing. You just don't create a new record, but you create a new index string schema, if you will. This is completely decoupled from your schema by itself. It's just basically an index representation that you then later on can couple to a schema. So it's completely independent. You can just say, hey, in general, I want to have an index on a specific property name, and later on you couple it with a schema that then hopefully has this property. This makes this very, very flexible. I can basically combine an index definition to multiple schemas, or the other way around. When you're starting to work with more flexible data structures, right? So I can mix and match index definitions, and that makes this very modular. In this case, the first one is just really creating one index, name index, on a property called name. The second one that you see here is I'm creating a compound index on country, state, and city, right? Once you're done with this, what you need to do is you need to take your schema representation and actually synchronize it with the server. So up to this point, every code that we've seen basically just happened on the Java side, right? We didn't actually talk to the Iris instance and create a class. That hasn't happened yet, right? That's what we need to do now. So we're going to, in this case, where we are here, we're going to call schema manager.synchronize schema, and we just handed over the schema string that we just created. The first one, the first line example that we're seeing here, is really just creating the schema class, in this case, user.person. If I also want to create an index on top of that class, I combine it with the index definition that we just created as a second argument and say, hey, use this schema and apply this index definition on top of it, right? So that's the mixing and matching that I just mentioned, right? So at this point, as soon as we've done that, we basically have a class representation on the server side that we can work with and ingest data. A couple more things we can do, I think very powerful, especially when we're working with, let's say, CSV files. We can infer the schema based on data that you hand us. So if I have, in this example, just an object holding a couple of data points, I can use the method infer from the schema builder and say, hey, take a look at this data. I want to create a schema with the name user.person. And you're going to figure out what the data types are. I'm not going to tell you that this is a string, and this is an int, and this is a double. You take a look at the data. You go figure out which column is which type. The only information that we need from you is how are you going to call these columns, right? So that's the third argument here called field names. And we're going to create them basically, in this case, name, age, city, country, and balance. That's how we're going to name these properties, okay? A very simple way, if you're working with dynamic data, you don't really know what they look like, and you don't have to walk your data and then try to figure out, hey, is this a string, is this an int? That's something we can do automatically for you. The second example is just basically the same thing, but if you have a table structure, what you would do usually, you just pick one of those rows and hand it through the infer method, right? And we go figure out which data types those are. That's the setup. As soon as we've done that, we can actually talk about manipulating data, right? Now I have my schema, I've defined my metadata. Now what I need to do is actually, hey, create a record, get it from somewhere, and ingest it, right? So I think that's pretty easy and simple to do. The first thing we need is actually we need a persister. We need an instance of the persister that we can interact with for all data manipulation. This is pretty straightforward. It just takes 3 arguments. First, you have to tell it what's the schema manager. That's the instance of your schema manager class that you're working with. Second, what's the schema I'm working with? I need to know what the metadata looks like. And the third is the argument for how we're going to create indices, right? Are we going to build indices right away through filing, or are we going to build them in a deferred mode, which means after the fact, right? Deferred is usually something that you select when you're doing batch ingestions, right? You want to file your data as quickly as possible, then create your index afterwards, after everything quiet down a little bit, and then queries can actually take care and utilize the index as soon as it's done, right? So deferred mode is usually what you use for batch ingestions. Immediate is something that you pick where you want to make sure that the new data set can be used through the index right away, right? And once you've done with that, I think that code is pretty simple. The only thing you really need to do is call the method insert and hand over your data, and you're good, right? That's basically everything. I think that code here is really simple and clean. In this example, we would create one row with the name Max, age 26, city is Berlin, country is Germany, and the balance of, I don't know, poor guy, 125 euros. Okay. Obviously, we can also work with arrays. So if you're not dealing with just one data set, but multiple, it's the same method, right? You just say insert, we get an array of objects, and we will just insert them in the batch, right? So I think a very, very straightforward API. Querying the data is very straightforward. This is basic SQL through JDBC. As you remember, right, we've created a table on the server side, so you can just use basic JDBC SQL statements to query the data. So in this case, we created a table called user.person. So we're just going to do a select star from user.person, and we get all the data back, right? Regular result set, going to iterate over that, and we're fine, okay? Very straightforward. Deleting the data, there are 2 options here. The first option is deleting the schema, including the data, and the second option is just delete the data, but leave the schema on the server side, right? Okay. That's everything I'm going to cover here for the Java Persister. If you're interested in that, we've been using and utilizing the Java Persister in a couple of very interesting projects to ingest data in terms of like millions of records per second. So that's been very interesting. There's more sessions to come on the Java Persister. I list them at the end, so you can make sure to take a look at those. The other news on Java is that we've been working on updating our Hibernate dialect. So we've updated the dialect to 6.1. And right now we are in the process of posting that to the Hibernate ORM group. So you will actually find the Hibernate dialect directly embedded in the Hibernate distribution. You just go to the Hibernate page, download the latest release, and that will include the Hibernate dialect. So you don't need to get that directly from us, but you still can if you want to. Okay, next section. Keep your client artifacts up to date. Something I encounter every once in a while when I talk to clients is that sometimes there's no clear process in place for updating, I don't know, the JDBC drivers, the ODBC drivers, and we realize that they're running on a really old version. On one side, I think it's pretty nice because what it says is this is very stable and it just works. Sometimes you just don't see a direct need for updating the clients because they just do their job, right? That's nice. I think we are pretty happy with that. But upgrading your clients gives you immediate benefits, maybe without you realizing that. So I want to highlight some of those. First of all, you will get transparent performance updates just by updating your client drivers. I'm not even talking about updating your Iris instance, which is something you should also do every once in a while, right? But updating your clients will also give you transparent performance throughput gains, right? A couple of examples here. ODBC now supports something that we call fast inserts. Fast insert is a technology where we basically create a package on the client driver directly, which can be consumed by the server and file the data directly. So the server doesn't have to do much data validation. The server can just take that package that it received from the client and store it on disk, and it's done. What this really does for you is the client is doing some work that the server usually does, and as soon as you have multiple clients which are distributed, that actually takes a lot of load from your server because many clients are doing a little bit of work. And that's work we're taking away from the server. So it means your server can perform better because your clients are doing more work. Okay? So that's one of the many transparent performance benefits you will see just by updating your clients. Obviously, I think this should be obvious, but going to mention it here. We're always updating the clients to make sure that we're reacting to security changes that are happening in the environment. Whenever something comes up in Java, in .NET, right, we're picking those changes up and making sure that you're running in a safe and protected environment, right? So updating your clients is also making sure that you're working in a safe and protected environment. So make sure of that. And usually, again, the process is pretty seamless, right? You can just drop in a new jar file and go from there, right? So that's pretty straightforward, non-disruptive. One thing I want to highlight for a second is columnar, which is something I think you've heard about probably last year when you've been to Global Summit. Columnar is now part of Iris releases. Columnar is a way of basically storing data inside in a table instead of in a row-based fashion, in a column-based fashion, which gives you benefits in a very specific workload, right? For example, when you're doing an aggregate on this particular column, then we can work directly just with the data set for this column instead of going row by row and extracting the value for this column, which makes the whole command run much more effectively, right? So here's an example how the clients help you with something like columnar. You've probably seen all the great numbers that Benjamin showed on main stage and in, I don't know, all kinds of press releases. We're saying, hey, columnar can make you run your analytics workloads run 100 times faster, right? Again, depending on the workload. So what happens if I have a server, I have a table which is row-based, right? These blue lines here are supposed to represent a row-based table. If a client tries to consume data from the server, what happens? Well, we can ship the row-based data directly, row by row, to the client, right? That's what you've been using for years in JDBC and ODBC. What happens now if I have a column-based table? Let's say we are working on an old JDBC driver, and the JDBC driver doesn't understand a column-based format. How are we going to ship that data to the client? So what's going to happen is the server has to do work, take the column-based values, transform it into rows, and ship those rows to the client, right? If we're now working on a new released version of the JDBC driver which supports columnar, the server can directly take those columnar data, ship it to the client, and the client can work with that. And the other way around, obviously, right? So that's a transparent change for you. You have to do nothing. But the client does a lot of work for you and makes sure that whatever you're doing on the server, work as effectively as possible with that data set. So making sure that you update your clients will make sure that you actually get the best out of everything that you're doing and utilizing on the server. Okay, so get into the habit of updating them regularly if we don't do that yet. To finish the story about columnar, it gives you transparent performance benefits, and there's actually much more work to it. So the developers are here if you want to and get an idea of what this actually entails. Talk to them. They're happy to share the stories. One example is columnar can be pretty complicated actually, and a table can, let's say, be mixed, right? A table can be row-based, but then one column is just columnar-based, right? Which basically means for the JDBC driver, ODBC driver, if you want to support this, hey, we're going to ship everything as a row except for this one column, we're going to ship it as a column. Right? What does this mean for error reporting, for example, right? If you're reporting stuff row-based, then yeah, for this one column, if that's columnar-based and there's an error in this one column, we need to take that error out of this column and put it into the right row so that we can report all the errors for this one row to you, right? So there's much more work behind the scenes that you're probably not aware of, and well, you don't have to be aware of it, but I think it's important for you to understand that the clients do a lot of work for you to make sure that you just can use it and run your SQL statement and be happy with it, right? Next thing, little sneak peek. As I mentioned early on, one of the next services that we're going to launch is the InterSystems Iris document service. So I don't know how many of you have played with the document model inside Iris. That's not it. This is a completely new, revamped version of supporting a document model. Running in the cloud, allowing you to work directly with documents inside a collection and working with data sets that are truly flexible and don't adhere to a fixed schema. These are a couple of mock-ups that I'm showing here. On purpose, I'm not showing you the real thing because you're going to see that tomorrow. But we're building this new service and going into an early access relatively soon. So if you're interested in learning more about it and signing up for it, please let me know, approach us. There's also more sessions about documents and also the improvements we've done for JSON and for SQL in general to work with flexible data sets that we're going to cover in these sessions. So here, a simple screen for how you can browse collections. Obviously, you can select, or you can query the data. The way how we do this is all strictly through SQL, which may sound weird because we're talking about documents. But there is something which is called the JSON table function, which allows you to basically flatten out a JSON structure and create a virtual table out of it, so that you can directly mix and match documents and join them with your relational tables that you have inside of your Iris instance. And that makes this a very powerful tool, because you can use one query language to just query, let's say, a JSON file you have sitting somewhere and combine that with a relational table. Next thing, and that's something important for every cloud service out there, you need import-export capabilities so that you can load your files into the system and actually work with it. No big magic. And you have some tools to index your collections and go figure out how you can work with those indices. I lied a little bit, so I have one slide with the real UI, just to show you that it's a real thing. Let's see if I can. No, doesn't work. Okay. If you're interested into it, there's one session which talks specifically about this JSON table function, which is very powerful and I think a wonderful addition to the JSON SQL standard. So it's not something that we came up with. It is part of the SQL standard, and we're adhering to that standard and extending it a little bit. I think it's a very powerful function which allows you to do a lot. There's a session about it at the Tech Exchange on Wednesday, which just talks about JSON and SQL, and I think that's something you should take a look at if you're a heavy JSON and or SQL user, because I think that will make your life so much easier. A little slide on all the early access programs that are currently running. So if you're interested in giving new features a try that we're currently developing, you will see lots of new cloud services that are currently in early access, and that list is growing. You can just sign up for them and experiment a little bit, play with them, and give us your feedback, and thereby improving the product before it actually releases. We're working on removing the private web server. So that's something which is currently also running in an early access. So make sure that you participate in this early access if you're making heavy use of web servers, because that's something where we're looking for feedback and want to make sure that this is as non-disruptive as possible for everybody. So we're looking for a good participation there. Foreign tables is a functionality which lets you basically work with tables that are not part of your Iris instance. They're somewhere else, right? Like an Oracle database, a MySQL database, or maybe just a CSV file. And let them treat them as a table that's local in your Iris instance. Okay, so a pretty nice feature. Integrated ML now supports time series modeling, which also is a nice addition. Take a look at that if you're an integrated ML user. And then we have 3 more sessions coming from the HealthShare group. Something Aya just talked about a little bit in her session like 45 minutes ago, if you're interested in that. Last but not least, here's the list of all the further resources for things we talked about today here. If you want to learn more about the Persister, there's a session happening on Wednesday afternoon right before the most important session about ice creams, the farewell reception, right? So that's a session actually going into much more technical detail and is talking about how we implemented the Java Persister in a couple of customer use cases, so putting more meat to the bone. I just gave you the sneak peek of what it looks like, what it does, and on Wednesday we're actually going to take a look at a real project. In the tech exchange, we will see lots of smaller demos, all about 15 minutes or so. There's also a session about the Persister on Wednesday right afterwards. There's a session about the Iris Cloud document service coming on Tuesday. Yeah, that's tomorrow. And my most favorite one, because it's about chocolate and peanut butter, about JSON table and SQL, that's also on Wednesday. So make sure to take a look at that. That's everything I have for today, and I think I'm right on time with 3 seconds counting down. So we might have time for one question or so, but if you have more questions, then just either reach out to me, just come find me. I will stay around for a couple more minutes, and we are all here until Wednesday. So with that, thank you for your time, thank you for listening, and I wish you a wonderful rest of the day and a successful conference. Take care.